Hello, everyone. Thank you for joining us today. I'll just make sure that everything is all right. And thank you for joining this session today about developing secure applications. We'll be going through, as mentioned, security focus on everything. We'll be talking about security risks, designing a secure application. How do we do it? Also, practically a few tips on scanning, on setting up if you're running your own servers, very quick security that you can do, and various free resources that are available to you as well. Feel free to ask questions throughout the session. You don't actually need to wait till the end, though we will have a Q&A at the end. You don't have to wait for it. I'll try and monitor the chat as much as possible, and I hope you do enjoy. And so let's get this rolling. So our agenda for today is, first of all, why do we focus on security when developing application? Any common security risks that you might have? Designing a secure application, what kind of frameworks do we have there? What are we supposed to do when we are talking about any applications? Security in the cloud, and any resources that you can use and leverage for securing your applications out there. And so why do we even want to focus on security when developing some kind of an application? What's the point here? I wrote 10 points here. And the points are really because, one, it protects your business from attacks. There have been instances in the past with the likes of Codespaces, which was a company that focused on backups for code repositories for customers. They got breached through different things, not specifically for their application, but the attackers got access to their own repositories, to their application servers, and practically held them ransom. And when Codespaces didn't pay, they just deleted everything. The second part is that it protects your customers' data. And that is going to tie into some other points, like number 5. When you do get breached, it impacts your brand. It impacts your brand, it impacts your reputation, it impacts your sales. Because the customers are not going to give you their money or information if they know that you're going to get breached. This is also where it helps you with regulations. A lot of countries out there, Singapore being one of them, Singapore starting to push regulations about security a lot harder on the industry and the markets out there. And that means also that you're not going to get fined if you properly maintain the security in your applications, organization, and even if you get breached, if you can prove that you did everything you could, uh, nobody's going to fine you. I mean, there have been a lot of precedents around that specific area that companies have proved they try to do everything they can, and nothing happened, compared to other companies that just ignored security and they got fined at the end. It boosts your customers' confidence. I've seen a lot of questions out there today when people are buying software asking, are you compliant with GDPR? Are you compliant with SOC 2, ISO 27000? Questions like that, because the people are becoming more wary about giving information to insecure companies. It can, we talked about reputation. It also helps you avoid downtime. The security is not just about encryption, right? It's not just about making sure nobody reads your information. Security also takes into account, how do you make sure there's minimal downtime? How do you recover as fast as possible? This is where security comes in. Reduces, of course, the risk of data breaches, helps you recover faster, saves you money in the long run, especially when you build security in from the start compared to trying to patch it up later. And it does give you sometimes a competitive advantage because some might prefer to go with a company that actually considers security better rather than a company who, well, just doesn't care about it. Now, we covered these specific, what's the point? And let's take a look at the common security risks that we usually see. Now, I'm not going to cover everything because you can find this online, and later also we will have this as a PDF handout with a lot more information in the notes, and it will be available on our website, and we'll provide a link later in a meetup group as well. That these comes from the OWASP top 10, the common security risks. Now, what is the OWASP? OWASP stands for Open Web Application Security Project. It's a non-profit. It's international. They have a group here in Singapore. They have an event this evening together with F5 in Singapore at Suntec. So you should check out their meetup group as well if you are looking at application security. And one principle that they do practice is that pretty much all the materials that they have is free. It's easily accessible. You can go to the website owasp.org and they make it free for everybody. Now, starting, I think, 2012, something like that, they started a project known as OWASP Top 10, which is they look at all the vulnerabilities that have been released over the last year or two or three, depending on the changes that are happening. The project is not updated every single year. I think 2021 was the last year. Before that, it was 2017 and the like. And they create a report which is updated, and it outlines all the top 10 issues of web applications that are available today. And when they look at the vulnerabilities themselves, they look, first of all, how prevalent it is out there, that people actually miscode or don't check or do specific, well, errors, you can call it, in coding. They look at how easy to detect it, how easy to exploit it, and what would be the impact if it was exploited. The different vulnerabilities would have different impact on your confidentiality, on your integrity, on your availability of the application out there. And so they do also the impact analysis around it. And that report is, again, free to download, so you can go to that website. Again, you'll get this handout later where we also cover all of it. If you are too lazy to go to the website or just not interested in that, you'll get this in the handout as well. The first most common vulnerability is injection. At some point, injection used to be #1 vulnerability, category out there for web applications. And injection means that somebody manages to put some kind of an input through your web application that shouldn't have been allowed. And doing that, for example, for various databases can yield different results. It can yield error pages that disclose the information of your applications. It can show if it's a really bad logic of your application, people can return all the users and their passwords back through that injection attack. And so that usually looks at how do you prevent this. So whether you do input validation, meaning what can people put in. You can see that happening a lot with the banks lately, at least in the last few years, that when you send a help ticket, at least I've seen it and noticed it, when you send a help ticket through their website, you're not allowed to use the double quotes, because double quotes are very prevalent in SQL injection, or double quotes or single quotes, which sometimes creates an issue. I write a lot with single quotes, like it's, and it doesn't allow you to send that form. So you have to go and fix everything where you used it. And so again, applications that do this do not validate the user information. which creates the issues right there. You would see that there are various queries that are not properly parameterized, that they can call across different regions and informations. You would see that sometimes the output is not validated, and so the web server would return things. So you don't want to do some of those things as well. Now, how would you go to prevent it? Of course, you need to separate your data from the various commands. You would try and use some kind of an API in between that completely avoid allowing the web application to talk directly to your data stores, to your MySQL databases or MariaDB, Postgre, whatever you're using. It can still create SQL injection. So we'll talk about various ways you can also do it. You'll be looking also at server-side validation, not again a complete defense, because there might be some queries that you try to run. You might to limit what kind of queries can be run, and to prevent different things, or you might even have security controls that are put in between. The one I am familiar with from a long time ago is active base, that allows you to stop information or change the query that is being sent from out there. So you are manipulating the queries that are being sent to your data stores, to your databases, and everything around it. The second, and we'll only for three today. Again, the hand notes on what it is, excerpts from the OS top 10. So you would see also identification failures, meaning that the systems give access to user accounts, even if it wasn't supposed to happen. Dropbox had a big issue with this, for example, 5 years ago, 6 years ago, something like that, that it doesn't matter which password you put, it would let you access that that login username that you were trying to log into. So if someone would put, I don't know, ilya.tivin@startsecurity.com, and without a password, they would get into Dropbox. Other types, when people try to do combinations on logging systems to see if any work, and it actually allows because it doesn't check errors, brute forcing. So those are all weak implementations. So the categories are very, very wide. It doesn't mean that this just doesn't check the password. It also means that it doesn't stop you from checking 50,000 passwords, one after the other. Some ways that we're looking on how do we prevent it. First of all is multi-factor authentication. Anywhere we can to prevent that credential stuffing, brute forcing, stolen credentials, even two-factor, we sometimes might want to do out of band, which means that if you're using your mobile phone for logging into an application, you don't want to request two-factor authentication on that phone. You would try and ask some different way. It might be security keys, it might be verification questions. There are lots of different two-factor authentication that we can talk about. If you are interested about two-factor authentication, if I'm not mistaken, we do have a free write-up on it as well on our resources tab. You might also to make sure that there is password length for users that are not limited. One of the things that drives me nuts is when you go to sign up to an application and it tells you, oh, you have to choose a password between 8 characters to 12 characters. Why? Well, what is the reason for that? If the system is old, upgrade the system so users can choose better passwords. My passwords, the password manager that I use generates by default 18-character passwords. And sometimes I have to change the settings when I do sign up to something to make sure it works. Make sure that when the application is built, do not hard code credentials into it. There's no reason to do that. There's no reason to hard code an administrator password into your application. And while some might say, well, that's obvious, apparently not, because companies still do that. There are lots of standards on how to use secrets, and I did reference a secret management tool in the resources at the end, which is Vault by HashiCorp. But there are lots of them out there. If you're using AWS have their own secret manager, Azure have their own secret manager. So you want to use a secret manager that will store your password, your tokens, your usernames without actually exposing it to the world and everything around it. You want to also limit attempts, meaning that if somebody gets their password wrong 5 times in a row, then they need to go through some kind of a account recovery process. Just like you have with your ATM, the ATM doesn't allow you to try as many combinations as you want. You get locked after 6. You can call, or 3, depending on the bank and the country. You can call probably, I know from experience that happened to me. You can call your bank, they will release it, but they tell you, hey, you only have 6 more tries. After this, your card is completely blocked. And the last thing, of course, is detection and service side built-in manager for session IDs and making sure that you properly use authentication there. So if somebody did connect, they don't stay connected forever. They get timed out. And this is extremely important if your application deals with very sensitive data. Just like your bank, you get logged out if you don't do anything for a specific amount of time. But when you log back in again, or somebody tries to log in, you get different session IDs, you get new communications so that nothing is tied to the previous information and the URLs and all the actions that you had. Again, if you do have any questions, feel free to put them in the chat. Happy to take those up. There will be time at the end in the last 10 minutes, 5 minutes. We'll see how this session flows and make sure to answer any questions that you have. The third one, which is interesting, and it's also a very broad category. It's pretty much everything that OWASP couldn't figure out where to put goes into insecure design. Though I am kidding. Now, insecure design is all the various different issues that you have when some kind of a control is missing. Meaning if your application is vulnerable to, I don't know, DDoS, or your servers are vulnerable to port scanning, well, you probably need firewalls, you need DDoS protection and things like that. This is where the design part comes in, meaning you don't have those controls in place. Now, they do a differentiation. OWASP do a differentiation between secure design, secure implementation, design flaws, implementation defects, because they have different root causes. And when you talk about secure design, it's where you know where to put the controls depending on the threat that you have. Now, I am not going to go into this because we did have a threat modeling session, and that was published, and it is available for download and watching, where we go over what is threat modeling, how to do it, and the like. So do watch that, and how to identify where do you put the different control. However, this is one of the important parts, because this comes when you develop, really even before you develop the application. You should know already where do you put your different controls. And this is the category that actually addresses that. Now, how do you actually prevent insecure design? You need to establish a secure development lifecycle. And we'll talk about several of those in a few slides. So we'll talk about a few, the benefits, why would we, why wouldn't we? And you would have somebody from a security expert about architecture design join in and help you do the entire threat modeling, which is very critical for all your authentication, access control, business logic, key flows. So the threat modeling is not just, oh, you put your web application on the internet, it's somebody can break it. That's not threat modeling. Then you'll be looking at how do you integrate security into the coding language, because there are guidelines out there if you're using JavaScript or Go or Rust or whatever it may be on how to properly document, how to properly write, which functions you should not use because they have been deprecated and insecure, or there are vulnerabilities about using very specific functions, calls, regex, and stuff like that. So that needs to be researched and be part of that security portion. Then you need to make sure that you have your checks, your testing, whether it is static testing, unit testing, dynamic testing, fuzz testing. We'll talk about that a little closer to the end. And also one large recommendation is always segregating. If you are building a multi-tenanted application and you're going to have a lot of customers logging in, is to try and segregate these customers as much as possible between itself. If you can, even segregate them into different sub-accounts. And the last one is always to prevent some kind of a DDoS to yourself, DDoS distributed denial of service that will take your service down. Try and limit the resource consumptions for users for some applications. And so the top 10 that have been recorded in 2021 are broken access controls, cryptographic failures, injection, insecure design, security misconfigurations, vulnerable outdated components, identification authentication failures, software data integrity failures, security logging, monitoring, and server-side request forgery. Again, I am not going to go through all of this today, but this is in the PDF that we will upload later on our website. And so when we look at how do we design a secure application, the first thing that we always need to do and talk about is the software-defined lifecycle, software design lifecycle, development lifecycle. Sorry. There are different approaches when you talk about development life cycles. Some of them are not in use today, such as waterfall. You don't see that as much. Waterfall is a very comprehensive and step-by-step approach that usually takes a lot of time. This equates to what you would see several years ago, or when you would go buy a software and every 6 months you would have an update, a large update. This is the waterfall approach where you finish working on all the features, you test everything, you make sure that the entire bundle is ready before you send it out. And the next phase begins only when the previous phase has been completed. You see iterative approach today that starts with a very small set of requirements, does not need everything that is going to happen to start this software development lifecycle. It's very repetitive, just like some of the others. And on each iteration that you do, a new type of software is being made. And usually each iteration is 2 to 6 weeks and develops a separate component on this approach. And now this requires more resources than you would usually see on the waterfall model, because you do have those set timelines that you keep going on. You would see the spiral. You don't see spiral too much because it actually just goes just like a spiral. It does work in an iterative model. It is a method that when you look at the risk of the project itself, you have to adopt more or less models depending on waterfall or the iterative approach itself. You have very small parts that you do the software in, and every functionality is added to the software continuously while you're still developing the software itself. You would see sometimes the V mode, which I forgot to put in. You would see sometimes the V mode, which is the same waterfall model, but you just have testing and development being done at the same time in parallel. This requires a lot of resources because one side is developing, one side is testing the entire thing. And again, you just keep going once each phase is done. And you would always, is today you mostly see everybody doing agile, which is a combination of the iterative focuses on rapid, yeah, I put something like this, focuses on rapid delivery of software. This is what you would see today from all your um, App Store or Play Store, that you see updates coming in sometimes day after day for the same application. And that's because you would see that you have the planning cycle. So what is it supposed to do? It's a bit more complicated than this image, but you would see your plan, you would see your design, development, testing, everything works, deployment, you get review, you get feedback, everything, you launch it, and you just keep going. A new cycle starts again. And this is what you would see through the agile thing. And in all of this, you would also see the secure software development lifecycle from Microsoft, which usually would go through the waterfall approaches or iterative approaches. It can also be incorporated into various or parts of it into an agile, and we'll talk about how security fits in agile models themselves. So this is the waterfall model, as we talked about. Traditional approach, development always step by step. Even security happens here step by step. So in every step, you make sure security is incorporated, and you do, whether it is secure design, whether it is secure testing, whether it is the maintenance around it. On application security for Agile, you would usually have several phases, such as requirements, design, development, testing, release, and it just keeps going between between release and development and the like. And you would see some of, and we'll cover a bit more onto these phases in a few more slides. You would see that, first of all, from the requirements gathering, such as what does it do? What do we need to do from a security perspective? Do we have regulatory needs? How do we have to keep the data? How do we have to, what kind of privacy do we have to provide? What kind of a training do we need to do to the developers? The developers do need training as well on how do we write secure code? What do we need to do from functions perspective and the like? And security requirements, also what do we need to make sure? So OWASP would come in here, right? We need to make sure there's no injection, the design is secure, and the cryptography is done correctly. So all of that has to come into these different phases. Then you'd move into your designs, where you need to understand how the data flows through the application. Because again, the threat modeling also revolves around data flows. You need to protect the data as it moves. And what do you need to protect? This is where the threat modeling comes in. And there are lots of different ways to do threat modeling. I think there are different, like 12 different methods, from Stride to, with all its different variations, to Pasta, to the HTMM. There's just so many of them. It doesn't matter which one you choose. Just make sure that it works for you. Then there's going to be an architecture review, how it is deployed, where is it deployed? Are we doing a 1-tier, 2-tier, 3-tier application with security controls and everything around it? You will have your development, This is where we're going to talk about static testing, meaning that we will load the source code of the application into some kind of piece of software. And there are free software that will do it for you. Then you're going to do the unit testing, meaning you'll check specific units one by one and make sure that it works and fulfills all your requirements. You will move to then to dynamic testing, where you'll try to run the application and have that security tool try and just break it. You would have your penetration testing. Somebody would try and get in and exfiltrate data and everything around it. You would have your integration test. How does it work together with other components? And after you release it, you will have your vulnerability management, meaning once you identified something, how do you fix it? When do you fix it? How fast do you need to fix it? That's also very important. If critical information or critical bugs, you might have to fix within a couple of hours, while low ones, you can wait a few days properly, probably. And how do you do the monitoring, such as knowing what is happening to your application, and the incident response on what do you do if something did happen? Somebody did get into information, what do you do? So these would be the security phases in Agile. And when you look at your Microsoft Secure Software Development Lifecycle, this is pretty much what you're going to see from the steps, from those iterative steps that you have to take. And I'm not going to cover everything, but this is some of the things that you would have to take a look at. Things like, do we have the security requirements? How do we have the design requirements? Did we put security? And of course, all the actions that you would need to do. Now, Microsoft, for example, threat modeling, they say assess threats using Stride, because specifically Microsoft came out with Stride, if I'm not mistaken, and they are still using that because it does apply for everything today. It's not the best, it's not the worst, it depends on your situation. Then static analysis, have you done reviews? Do you have a release archive? So all of this is being accounted in the Microsoft Secure Development Lifecycle. Some of the things that we were talking about earlier in secure design, coding, pen testing, everything, what things do we have to keep in mind is when we are talking about secure design, you always have to think about how do you reduce your attack surface, how do you do defense in depth, how do you make sure that the principle of least privilege is there, and how do you make sure that your application always goes back to secure defaults, meaning if there was an error, there was a bug, something broke, you shouldn't have your application just open everything and everybody can access. Well, just like with the Dropbox case, right? The authentication mechanism broke. So we shouldn't allow everybody to go in. We should do the opposite. While it might be bothersome for users, we should block everybody from coming in. Then when we are talking about the threat modeling, take a look at the which model you're going to use, the implications of the threat model that you're going to put in, and the coding constraints based on your threat model out there. You're going to look then on the secure coding, such as buffer overruns, integer errors, cross-site scripting, SQL injection, weak cryptography, all of those. Security testing and functional testing. Do your functions work? Does your security work within those functions? How do you do the risk assessments, and how do you do the security testing? And at the end, types of data, sensitive data, best practices for privacy, for designing. Singapore CSA, Cybersecurity Agency, released a large document for secure by design on how to design applications securely. It's free. I do recommend to go and read it. So there are lots of different actions and keystones that you would need. Again, in the handout, There are a lot of notes that would guide you on everything that you would need, such as which questions do you need to ask from a requirements perspective, such which portions of the project will require threat models before release. What is the privacy impact of specific functions or releasing it? Do we have a privacy rating impact on this data? So there are different questions that you're going to need to ask. Again, this will be in the handouts, and I'll try and make sure to, if you do also have any questions, you can email me and I'll try and reply it. And then we are talking about always design as well, about the security features, the functions, attack surface reduction, meaning if we don't need a specific feature, if it's a really nice feature to have, but because of it, our application becomes so much more secure, well, we probably might not need that feature. And there are a lot of things that we do have to consider here. Now, when we are talking about the cloud, and this is where I also do a very quick demo, not about the coding, more about the deploying the application. When we are talking about cloud and having our applications hosted in a cloud, and just in case you're not familiar, I also started up a group called Self-Hosted Singapore that we're talking about, well, hosting yourself things instead of deploying it and lots of different things. So when we're talking about cloud, software changes a little bit. Now, you do have a lot of opportunities moving your software to the cloud. So you are looking at higher baseline security. Now, if you look at a cloud, you have three models: infrastructure as a service. You get the same security pretty much as you would have at home. A platform as a service that you write the code and it builds and deploys your application there, or software as a service that you just buy ready software. Now, if you're developing your own software, you'll probably be going for those two lower tiers. And if you go to a platform as a service, you do get that higher baseline security, meaning the platform itself is managed and secured by the provider. Now, of course, to have those benefits, you actually need to choose a reputable provider. So you would not go to Iliativin Hosting Limited, because by security right now, from a provider perspective, it's not extremely reputable. There's zero reputation right now. It doesn't exist. And you would prefer to go to AWS or GCP or Azure or Ali Cloud or Huawei Cloud or anything like that. You would probably not go for, I don't know, CopyTM hosting. So you would also see opportunity and benefits on the responsiveness and the agility. You would see isolated environments out there. It's easier to isolate everything for customers, et cetera, and even just replicate your software fast. You can workloads for different microservices that you're building. You would see your elasticity. In a lot of the platform, DevOps is integrated. We'll talk about that on the next slide. And a lot of the interfaces are unified. So your CI/CD pipelines are continuous integration, continuous deployment pipelines are all integrated in with all your infrastructure templates, your code templates, everything is managed for one interface. However, we also have challenges. One of them is the limited visibility that you give away. You have no idea once you deploy your code what happens underneath it, on which versions of the platform does it run. If you need Ruby on Rails framework and you go and build it on that platform, you don't know which version runs there. You don't know if somebody logs in from the administrators doing changes or anything like that. You do have an increased application scope, meaning that you do need to manage much more. From all those interfaces and et cetera, a lot of other users and things like that. You would have your changing threat models, which now you need to account also for various administrators coming in. You need to account for, well, if somebody attacks AWS or a different tenant on your server, then you will also get impacted. So that is where you'd see those change in threat models out there. And there is a general reduced transparency on what happens in the backend, the platforms, the update, the patches, and all of that is gone. You don't see that anymore. Then we move into DevOps. DevOps really is a combination, well, implementation of Agile into testing and everything around it. So you'll see from this entire thing, where we go, that you start with the planning, you go into writing your code, building, testing the code, releasing the code, and this is where you'll see the move from development onto operations. The operations is green. The release, deployment, operations, monitoring, and every time you would have new feature, bugs identified, etc., it would move back to plan, code, and just a continuous cycle forever. One of the things you hear a lot lately is DevSecOps. Um, DevSecOps is not intimidating. DevSecOps just literally means this. It is how do you take security and you integrate it to that DevOps lifecycle. That is DevSecOps. So from the designing, pretty much everything we talked about, how do you properly design, how do you code securely, how do you build securely, test, deploy securely, protect the application. This is where security comes in. It's a real buzzword. This has been happening for years. Just somebody decided to invent the DevSecOps, I don't know what even to call it, naming or whatever. So it has been there forever. It's nothing new. It's just how do you rep DevOps under the umbrella of security. So how would we go about securing something? So I do hope you can see this. I think, okay, there we go. So I created a VPS for this entire demo. So if something does not work, I do apologize because everything happens live, and this is really a fresh install of everything. So what we're going to do is, I know a lot using various cloud resources and everything around it. And if we, again, this is a brand new install from less than an hour ago. So it hasn't been scanned yet by anyone, so that's okay. But eventually it would be scanned. And always when we are starting something and it might be exposed to the internet, which I don't find as many issues with exposing something to the internet as long as you properly protect it. Of course, if there is confidential information on something that you can't ever lose, then it should never be exposed to the internet. Because the moment you expose it, you are in an issue. So always the first thing that I do on any new server is I always install. Let's not do the upgrade yet. I always install fail to ban. Fail to ban is a very small package that what it does, it monitors your SSH server. And if anybody tries to connect to it and with the wrong password after three tries, it just blocks them. Another thing is that when you are running any type of instance or anything, don't ever use root, because everything that you install under root would get those same privileges around it. So you can see fail to ban has already been installed. And we can always just can test it. If we always want to have it run up, then we always need to enable it. And there's just another configuration file that you'll be editing, and pretty much that's it. Although from a configuration perspective, this pretty much should already work. I need sudo for everything. I keep forgetting. So from a configuration file, you can pretty much just copy this file and everything should already start working around it. That's pretty much the first thing I always do. Now, once you have done the configuration, I always let's take a look at how do we run WordPress. It's just why not? It's a web application. So let's take a look at running WordPress itself as some kind of a web application that we might have. Now, this is a Docker install that will install and expose automatically the IP address. And we'll see how we can block it also from the entire world from coming in. There are different ways for us to do that, whether it is through the built-in firewalls or anything around it. So this is the WordPress. It listens on the IP itself, which we might want to change later. I think it's port 8080. There we go, 8080. And there we go. We have an installation of WordPress. Now, this will all be gone once we, of course, finish the session. So the installation of WordPress is there. One thing that we can always do if we want to check if we're running Docker or any dependencies, we can always go and to Trivi, which is done by Aqua, and we can scan various Docker containers and everything around it, even our Docker containers that we have developed, the applications, and just make sure that everything is properly protected, vulnerabilities. You can see WordPress, the latest, you can see seven critical vulnerabilities and everything around it, which I see a lot of the time people don't check the Docker layers that are coming in. So this is quite critical application that we have there. So we can always enable UFW. For example, here it is the built-in firewall. So we can just turn on the firewalls that we have. Should be enabled already, or maybe not. Proceeding with operation, yeah, might kick me out. Okay, firewall is active. We want to enable, of course, the port that we have for WordPress. Everything else will be blocked. We can put it to a specific IP. So if you are doing, for example, specific IPs, then you can do it from specific addresses or things like that, which is also a possibility. Now, I can always also block the incoming ports. And what we can always do is use various tunnels or reverse proxies to put the information in, which the reverse proxy, if it has different protections, can stop the information coming in. One of my favorites is Cloudflare tunnels. Cloudflare tunnels allows you to use the Cloudflare distributed networks, everything around it to actually allow information in. Unfortunately, we're coming at the hour, so I thought I'd be able to demo it. This will have to, I'm going to demo Cloudflare, I think, next week or in 2 weeks on the next session that we have. So I do apologize. I won't be doing Cloudflare today, but do join the next one because We do have very limited time coming to an end. And just a few resources that you would have. We do publish lots of free resources out there. You have links for the Microsoft Secure Development Lifecycle. If you want static code analysis for free, there are free tools. One of them is the Sonar Cube. Sonar Cube is a free open source static analysis for applications. I think it only runs on Windows, if I'm not mistaken, but it allows you to scan your code for free. Another tool that you can take a look at, this is a Singaporean startup that they allow you to manage open source that you may use for your project. And they have a developer license, if I'm not mistaken, also for free. Trivi that I just showed you for scanning the different images. We have various online assessment resources that we also publish on our GitHub. If you are using reverse proxies, you do have an add-on named CrowdSec, which is you can call crowdsourcing, threat intelligence, and blocking. Cloudflare, which I love, I'm a big supporter. And if you are using secrets and passwords and management around it, take a look at Vault Project by HashiCorp. It's also free, and how it can be integrated into your various applications. So I just wanted to leave a few minutes for Q&A. I do apologize, I did not finish my demo. The demo was a bit larger. I just do want to leave time for Q&A. So I open it to everybody. Feel free to use the chat. And again, this will be a handout on a PDF that you could download and take a look and reference and everything around it. The session will also be recorded. So we are here. Thank you very much, everybody. If you do have a question, please type it in the chat and we'll happily answer any questions that you may have. I'll be here for another few minutes. Again, if you do have questions, please feel free. Otherwise, thank you very much, everybody, for today. I hope it was beneficial.